So welcome to the most aggravating video in the entire course, because this is the one where we run into all the algebra issues that actually don't work. So I have this thing here, it's a parabola, and I've been asked to solve when that parabola has a value of -1. Now if you're really good at translations and transformations, or if you just remember from grade 10, you might be able to look at this parabola and you might be able to figure out why this doesn't have an answer. And we'll cover that once I get through the math part. But for the time being, I'm just going to try and solve this like anything else. I take the function 2x minus 1 squared plus 3, and I set it equal to the value I want. To kick this over, like always, -1 subtract 3 would be -4. Divide both sides by 2. -4 divided by 2 is -2. And then I have to sum in the antifunction for squaring, so that would be plus or minus the square root of -2. Okay, now square root of 2 isn't a clean number. It's 1.4 or something. But that's not the problem. It's not that it gives me a decimal that I don't like. It's that you can't actually square root a negative. So this is forbidden. So what I've figured out there is that there is no x value that would make this function spit out -1 as its output. Now you need to be very careful when you're doing algebra, because this will happen to you sometimes. And there is a habit of getting a negative in a square root and then just waving it off and saying, oh, I must have made a negative error. I'll just square 2 instead and carry on with that answer. But you'll be wrong, because I've asked the algebra for an answer and the algebra has said to me it's not possible. And that's the truth. This function never returns that value. And to sort of show you that, if I were to do a quick sketch of this thing, this is a parabola that has been shifted to the right 1 and up 3. So it looks like this, approximately. I mean, I'd need to transform it, but that doesn't really matter. What I asked for is, when does this function cross -1? When is it down here? Well, it's never down here, right? It doesn't go that far. So if you asked for this value and then just said, well, whatever, I'll make that 2, and then carried on, you would return answers when no answer is allowed. So don't do that. When you get something like this, a square root of a negative, go back and check, because it is possible you made a negative error. But you need to make sure that it's an error and not the algebra trying to tell you that the thing you're trying to do doesn't have an answer. So there's 3 other circumstances where this will happen to you. So I'm going to do one example of each, and then it'll be off to practice problems. Okay, so this one's a rational expression. Looks harmless enough. So we'll carry on. 2 over x plus 3 plus 4. I want to know when this function is worth 4. So I'm going to kick this 4 over. 4 subtract 4 would be 0. And I could try and use the rational operator, raising it to the -1, or I could just do some cross multiplication. So I think I'm going to do that. I'm going to do 2 equals 0 multiplied by whatever's down here. Okay, and you're going to be very careful with this. 0 times x is nothing. 0 times 3 is also nothing. And 0 plus 0 gives you 0. And so I end up with this little sentence sitting on my board. 2 equals nothing, which is false. So in the last example, I had a domain error, right? Like I tried to shove a number into a square root that was forbidden. And here, I ended up with something that was flat out factually untrue, right? 2 isn't the same as nothing. That doesn't need any further explanation. But if this happens to you, the algebra is telling you that this function can't equal 4. And again, if we try and justify it through a sketch, and hopefully you covered this well enough in grade 11 that this makes sense. This is a rational that has been shifted to the right 3 and up 4. So it's something like this. Right 3, up 4. And rational expressions look like this. Hopefully you remember seeing these in grade 11. You're going to see a lot of them in the next unit. Hooray. But that's 4 right there. This particular type of function has a horizontal asymptote. And that means that this function drops and approaches the asymptote, but it never actually reaches it. So when I asked for 4, I was asking when this function actually hits the location of its asymptote, which it never does. So the algebra told me that that was false. It couldn't happen. So if you are trying to work with a logarithm and you are asked to evaluate, say, f at 5. So we're going to put the 5 into that expression like we always have been doing. F at 5 is 4 log 3 of 5 minus 7 plus 2. So order of operations, I have to do this first. 5 minus 7 is negative 2. It's a lot of stuff to write. And then we have to do this part to finish simplifying the argument. So 3 times negative 2 is negative 6. And then I have to log negative 6. So if you try that in your calculator, you end up getting a domain error. And if you recall any of the sketches we've done for log, this particular thing fails. Because this number, the argument of a logarithm, can never be less than 0. Let me write that down. It can't be 0 either, I guess. It can't be 0 or less. So if you are working through an evaluation question on a logarithm and you get to this step and the number you have to let log act upon is either 0 or negative, then you're going to end up with a fail because sometimes it doesn't work. If you're trying to work with an exponential, I have a base 2 exponential here, and I'm asked to solve for a particular value. Just like you always do, you take this and you replace this thing here. So 6 would be 3, 2 to the power of 5 times x minus 3 plus 7. And you go through your algebra process, steadily eliminating what needs to be eliminated. I'm going to have to move this thing first. So 6 minus 7 would be negative 1. And the next thing to move is this 3. I break multiplication by division, so I end up with 1 divided by 3. That doesn't go clean, so I'm just going to leave it as 1/3. Leave it as its fraction form. 1 divided by 3. Now, to break an exponential, I need to use a logarithm. And because this is a base 2 exponential, I need a base 2 logarithm over on that side. And then only the exponent is left over here. But if you look at what's happened, I've got a negative number inside of a logarithm. And from that very last example where we tried evaluating a logarithm, if you feed this thing a 0 or anything that's negative, it fails. Jot that down there. So because this logarithm failed, this exponential can't actually ever equal 6. And if you were to sketch it, which we haven't gotten to quite yet, but on a little axis here, this exponential has been moved up 7. So if I dash that in there, that's at 7. And exponentials always look like this, long tail, and then they take off. If you look, 6, y equals 6 is here. That exponential will never reach that value because the asymptote won't let it cross in order to get down there. So a picture would show you that. And the algebra will show it to you too, because this happens. You have to feed either a 0 or a negative into a logarithm. So the last example we're going to do is a trig function. I'm going to do a sine one, but the same algebra problem will occur for a cosine. If you can see this one in your head, this sine function has a midline at -2, and it has an amplitude of 3, which means it is at most 3 squares above -2 and 3 squares below. So if you can picture that in your head, 3 squares up from here would be 1. 3 squares down from here would be -5. So this function should wiggle back and forth between 1 and -5, and I've asked when it hits -6, which it obviously doesn't, because sometimes it doesn't work. So I'm just going to show you where that error shows up in the algebra. So you set the function equal to the number you're after, as always. Okay, kick this 2 over. -6 plus 2 is -4. Divide both sides by 3. Uh, 4 divided by 3 would be -4/3, so I don't have to write the decimals. And the anti-function for sine is arcsine. And this is also forbidden. An arcsine can only accept numbers between -1 and 1. An arc cos can only accept numbers between -1 and 1. So if you try to take the arcsine or arc cos of a number that is bigger than 1, either in the positive or negative direction, it's going to fail on you. As it should, because this sine function never actually goes that deep. So you'll maybe notice as you've gone through that the error, like the line in your work where the error occurs, has always been the place where you conjured the anti-function. And that's because these functions have a thing called a domain error. There's a set of numbers that they're not allowed to accept. So as soon as you flip from sine to arcsine, or you flip from e to ln, or you flip from square to square root, that anti-function pair is the type of function that has a restriction on the type of numbers it can eat. So if you try to feed it something that's not going to work, then it chokes on it and the whole process fails. So you should probably make a note to yourself which functions don't work and which values they don't work for, so you can hunt for them. You should try and train your brain to see these things as pictures so that you can maybe take a guess at whether or not they work. When you get to the practice problems, some of the questions do have answers, some of them do not. Before you start into the algebra process, you should try that. Try and see what it looks like in your head, and then once you can see what it looks like in your head, ask yourself if it actually hits this value. And if it doesn't, carry out the algebra expecting it to fail. If you think it does hit that value, then carry out the algebra expecting it to work. If there's a mismatch between what you expected and what happened, then you'll have to go through and either revise your picture or maybe hunt for the negative error or what have you that was made in the algebra. Okay, good luck.